Now let me solve problem 2. And the question 1, the wide sense stationary process. A stochastic process x of t is called wide sense stationary if its mean is constant, which is e of xt, its mu. And its autocorrelation depends on only tau equals to t1 and t2, the interval between t1 and t2, which is the expectation of t of t plus tau multiply x of t. It is equal to r of tau. It is only the function of tau. Explanation. This xt is a kind of stochastic process, which its expectation value do not depend on the time, and its autocorrelation only depends on the time interval. Whenever t1, the value of t1 or t2 is, it is only depends on the t2 minus t1, the value of t2 minus t1. And the second question, the independent increment process. And the definition in the book, if the increment of x increments xt2 minus xt1 and xt4 minus xt3 of a process x of t are uncorrelated, which means they are also independent. For any t1 less than t2 less than t3 less than t4, then we say that x of t is a process with uncorrelated and independent increment. And the explanation. When there are two intervals are non-overlapping, the random variables in those two intervals are independent, and that is the independent increment process, and which also means that two different time periods which is non-overlapping and are independent with each other. And the third one, the Markov process. This is the definition for t1 bigger than t2, bigger than t3, and more and bigger than tn. The xt is a Markov process if the probability of x of t1 less or equal to x1 when given xt2 equals to x2, x of t3 equals to x3, and so on, and xtn equals to xn. It is equal to the probability of xt1 equals to x1 when given xt2 equals to x2. This is the definition. And explain. This is a process that if we know just a time point, which is maybe the t1, and we do not, it is not necessary for us to know the past time point, the value of the past time point. We could also get the value of the future point. That's which the Markov process mean. We could get the future value of the of this process with the value of the current time. It do not depend on the past time. And then the question 4. The strict sense stationary process. The definition is a stochastic process xt is called strict sense stationary if its statistical properties are invariant to a shift of the origin. This means that the processes x of t and x of t plus d have the same statistics for any c. And explanation. This means that the time shift does not affect the statistics of the xt. It is do not depend on the time. Then the fifth question, the white noise. The definition is we shall say that a process v of t is a white noise if its value v of t1 and v of ti and v of tj are uncorrelated for any ti and tj when tj do not equal to ti. This means the correlation of ti and tj equal to 0 when ti do not equal to tj. Explanation. The white noise process is a kind of process that when we pick up two different time and there are two different random variables, and these two different random variables are independent with each other when the time when we pick the time point are different with each other, which means that when we pick t1 and t2 and t1 do not equal to t2, the random variable of t1 and the random variable of t2 are independent with each other. This is the white noise. Each different time are independent with the other times. So that's all the explanation of the problem 2.